In this video, we're going to be looking at how we actually use the finance formulas. We're not going to actually be solving with them and finding all the answers with them per se, but it's more of just making sure you know how to actually use the formulas and put the information in the right places. So for each problem, we're going to state which finance formula you should use. Then for each formula, you're going to state which quantity you have and which you need to find. Then you're going to put the numbers in the right places in the formula for the correct quantities. You do not need to compute anything after that. So let's look at the very first problem. In this problem, Gene bought um, a washing machine for his rental property with a credit plan of $35 a month for 3 years at 12.5% APR. What was the purchase price of the washing machine? And how much interest will Gene have paid at the end of the 3 years? So this looks like we're talking about doing a credit plan. So this looks like we're looking at a loan formula. So the first thing we're going to do is we're going to write out the present value of the loan formula or the payment for the loan formula. But we want to know how much the purchase price was. So we actually want to know what the present value was. So we want the present value formula. And in that formula, you're going to have your P. So that formula is P, present value is equal to your payment, times 1 minus 1 plus R over N to the negative N times T all over R over N. So now we have the right formula that we need to look at. To know it's the right formula, we have a credit plan. We're talking about how much we purchased it for. So that tells us we're looking at the payment value. I'm sorry, the present value. So then what you do is you think about what each letter you have. You have a letter P for present value. You have PMT for the payment. You have R for the interest rate. You have N for the number of compounding periods, and you have T for the number of years. So those are all the letters I see in this formula. And your job is to figure out what each one of these letters stands for. So looking up here, what we know in this problem is that we have a washing machine that we're buying with a credit plan of $35 a month. So $35 a month looks like a payment. So that would be our payment of $35 a month. Then we see it's per month. So that tells me my number of compounding periods is 12 because there's 12 months in a year. I then see that we're doing it for 3 years. So that's my number of years. That's my time is 3 years. And I also see that I have a 12.5% APR. So that's my interest rate is 12.5%, which I'm going to convert to a decimal. Always convert your R to a decimal from the percent. So the only thing I don't know is my present value. So that's what I need to go find. So I'm going to go ahead and find that present value. It's what we're looking for. So we're now going to put everything in the formula that we have. So P, we don't know. That's my question mark. You can either write a question mark or just leave with a P. The PMT, we know is 35. 1 minus 1 plus. My R is 0.125 all over my N of 12 raised to the negative N, which we know is 12, times my T, which is 3, all over my R of 0.125 again, over my N of 12. And there's my formula, putting everything in place for it. You would now need to do a little bit more work to this to find out everything that you need and calculate that. But that's part of your 142 class, not part of this course. This course is just making sure you know how to put things together. It does ask us how much interest will Gene have paid for the at the end of the 3 years. We can still set that one up. We don't actually have a formula for that. So let's just think about what this would be. So what we need to think about, whoops, I can't spell interest, is we need to think about what would it mean to be an interest and how much would that be? And so what you're going to look at is you're going to look at how much you actually paid for it was your present value, but then you're also going to look at what your payment is. Your payment times how many payments you made. Well, you made 12 payments a year or N times the number of years. So you're doing your payment of $35 a year times my N, which is my 12. I'm doing that for 12 months, and I'm doing that for 3 years. So that's how much I'm actually paying in the long run for my object. I don't need to do anything more than just think about this is how much I'm paying for it. Then I can subtract off how much did it cost to buy it in the first place. So then you just subtract off that principal, which we still have yet to find, but that's how you would do that. This is a great thing to do when you're doing any kind of loan, is think about how much are you actually paying for interest in the end by just taking your payment times N times T and then subtract off how much you're paying, for, how much the object costs. That tells you if it actually makes sense. I still didn't spell interest right. Okay. Now let's go to the next problem. The next problem says, suppose you need $1,230 to purchase a new TV in 2 years. If the interest rate of a savings account is compounded quarterly at 3.8% APR, how much do you need to deposit in a savings account today? So looking at this problem, it looks like we're talking about putting money in just one time because we're just depositing it today. So that looks like it's just one time being deposited in the account. And that makes me think it's not a payment plan. It actually looks like we're just putting money in an account and letting it sit there. So that looks like a compounding interest problem. The reason I know it's compounding is because I see this word compounded. So I'm going to grab the compound interest formula, which was F is equal to P times 1 plus R over N to the NT. So now I know I have the right formula because I'm just depositing one time. I'm looking at compounding, and then I want to find out how much I will have. Um, and actually, I need to know how much I want to deposit today, and I know how much I'm going to get in the future. So then again, now look at all your letters. I have an F, I have a P, I have an R, I have an N, and I have a T. So let's see if we can figure out what things are. We need 1230 in 2 years. So we need that. That means that what we need in the future. So that must be my future value. So that's the 1230. I knew I need it in 2 years. So my time is 2 years. If my interest rate is compounded quarterly, quarterly means we're doing it every quarter, and there's 4 quarters in a year. So my N is 4 for 4 quarters. And my interest rate is 3.8% APR. So that's 0.038. Make sure you convert that decimal into a percent. Then the only thing I don't know is my P. So now I'm going to go ahead and put all the numbers in the right places in the formula. I know my F is 1230. I don't know my P. I can either write it as a question mark or leave it as a P. 1 plus R is 0.038 over top of N. N was 4. Raised to the 4 times 2. And again, we're not going to solve this. We're just trying to see how do we put the numbers in the right place. Isaac is saving his $50 monthly allowance by putting into an account earning 4.5% per year. How much money will he have at the end of 5 years? So this looks like a problem where we want to know how much we want at the end of 5 years. So that looks like a future value problem. So it looks like we're looking for a future value. We're talking about putting money into an account every year. So we're looking at putting 5%, I'm sorry, $50 monthly into an account. So that says that my payment, we're making a payment. So actually I want to do this slightly different. So we're doing a payment is what we're dealing with. And we're looking at kind of what that's happening. And so that says to me that it's a future value of the payment. Going to my formulas, there's a future value is equal to payment times 1 plus R over N to the NT minus 1 all over R over N. So I then got this formula because if I look at this, this gives me all the things I need to work with. I'm making a payment and I want a future value. And this payment is a payment to myself, so it's a savings account. I'm making a savings. So again, I'm going to look at F, PMT, R, N, and T. So those are the things I need to know. So future value, that's what I'm looking for. I need to know how much money I have at the end of 5 years. So the future value is what I'm looking for. My payment, I'm making $50. My R, my annual rate, now that actually is an annual rate of 4.5% per year, which would then convert to a decimal, 0.045. My N, because I'm making a monthly payment, my N has to be that 12, because it's 12 months in a year. Even though it says my APR is per year, I'm going to have to assume my account is going to pay that monthly. And then I'm looking at the end of 5 years, so T is 5. So the only thing I don't know is my future value. Again, now putting everything in here, I can either put a question mark or put F for future value, put 50 in for my payment, put 1 plus R. My R was 0.045. We're to compound that quarterly, so 12 to the 12 times 5 minus 1 over 0.045 over 12. So just putting all the numbers in the right places, having the numbers and letters sitting here helps you to put the numbers in the right place. All right, the next one is that Susie purchased $100, sorry, 100-year treasury bond for $10,000 at 4.4% simple interest. How much will she have in 10 years? So in this problem, we're dealing with simple interest. It even says the word simple interest. So that tells me we're going to use the simple interest formula, which is F is equal to P times 1 plus R times T. Again, it helps to write down all the letters I'm dealing with. My F is, I want to know how much you'll have in 10 years. So I'm looking for how much you'll have in the future. So I don't know what F is. P is how much I started with, and I bought a $10,000 bond. So that's my P. My R is my interest rate of 0.0448, 4.48%, changed into a decimal. And then we're going to do this for 10 years. So T is 10. So I have that F is equal to 10,000 times 1 plus R, 0.0448 times 10. Again, once you know what all the letters stand for, you can just replace them in your formula. And one last problem. My deposits 1,500,000 in a continuously compounded account earning 2.3% APR and now has a balance of $2,250,000. How long was the money in the account? So first thing I notice is it has this word continuously compounded. So I look for these kind of words when I'm doing these problems. And since I saw that word, I know I'm using the continuously compounding formula, which is F is equal to P times E to the R times T. F, P, R and T are my letters I'm working with, so I just write those down. F is always my future value. It's what I have in the future. So it says we deposited this and we now have a new balance. So this is new balance is what I have in the future. 2,250,000. My present value is how much I started with. Well, we deposited 1,500,000. So that's my present value. I see I'm doing 2.3% APR. So that's 0.023, changing my percent to a decimal. And I want to know how long is the money in the account. So I don't know what T is. That's what I have to find. Now, again, I'm going to put all the numbers in using my formula. So I'm going to replace F with the 2,250,000. I'm going to replace my P with the 1,500,000. I have this E, which is actually on your calculator, to the R, which is 0.023 times T. Again, we're not solving in this class. We're just looking to see how do we set these up. So this is how we set up some of these. If you notice the process you want to go through, figure out which formula you want, write down all the symbols, all the form letters are in that formula, find out what all those numbers are there, and then plug in all the ones you have, and then solve for the one you don't know. That's kind of the process all these go through.